So these examples aren't in your notes, but I think some of you might need a little bit of practice here. When we have solutions that look like this, we often like to see our answers written over a common denominator. We also want to be sure that we've simplified our radicals. So let's look at these examples. In the first one, all we need to know is that this needs to be written over a common denominator, and right now the 3 is written over 1. So you remember from our work with fractions that you would multiply by the missing factor, and it's only the first term that we need to multiply by. The second term already is over 2. So now that I can write everything over 2, I have 2 times 3 or 6, plus the root of 21 all over 2. There's no simplifying that can happen here. I know some of you want to divide out this, but you can't. 6 is not a factor, it's a term. Remember, I've said this many times, factors multiply, terms add and subtract. The second thing we want to remember to do is to rationalize our denominators. So you can see in our second example here, we have a square root of 2. So the first thing we want to do is multiply that by root 2 over root 2. So now we have 1 minus, well, I could write the root of 44, but I remember that it's easier if I just prime factor first, all over 2. Now when I look at this, I see I have 2 factors of 2 that can be taken out. So this is 1 minus 2 root 11 all over 2. Again, we want this over a common denominator. So we need to multiply that 1 by our missing factor. So we have 2 minus 2 root 11 all over 2. And why don't you go ahead and try this one? So you multiplied by root 3 over root 3 to rationalize the denominator. And I know that I can simplify that square root of 8. So rather than writing the square root of 24, I just prime factored. I have 2 factors of 2 that can come out. This time my common denominator is 3, so I'm going to multiply the first term by 3 over 3. So we have negative 15 plus 2 root 6 all over 3.